Hi there, welcome to this course on Absolute Introduction to Object-Oriented Programming in Java. This course is focused on deconstructing what is a class and what's an object in object-oriented languages and how to involve multiple classes to write your programs. And the knowledge you gain in this course is transferable to all object-oriented programming languages. And since Java is the most popular programming language in the world, I'll be explaining object orientation using Java in this course. But understand that the stuff you learn in this course is transferable to many other programming languages because object orientation is the most popular programming paradigm. You must understand it, and it's being used throughout in most software projects in the industry. Now, the concepts about Java and how object orientation works in Java actually start from the next lesson onward where we start to code, but I wanted to create this lesson for those viewers who have absolutely no idea what a computer program is. So if you've written simple Java programs in the past and have been able to create your own methods, you can skip to the next lesson, but I'd recommend you still stick around to hear me out because I'm going to really build your foundation on some important concepts about organizing computer programs. Irrespective of the programming language you choose, it all works exactly the same as I'm about to explain to you here. So the question arises, what really is a computer program? The simple and most correct definition is a computer program is a list of instructions to the computer on how to perform a given task. All right? That's all it is. It's a list of instructions that you give to the computer and the computer performs those instructions, all right, to complete a given task. So I'll give you an analogy. Let's say I write down the list of instructions on how to change a flat tire, and I hand over these instructions to a friend who has never done this before. I need to make sure that I'm as explicit and detailed as possible, and the instructions can go something like this. In case the tire goes flat, pull over the vehicle as safely as possible to the side of the road. Open the car's trunk. Locate the wrench in the tools compartment as well as the jack that you're going to use to hoist the vehicle up. Head over to the flat tire and loosen the bolts of the tire. Then you place the jack underneath the vehicle and crank the jack to begin raising the vehicle up. And keep cranking until the tire has been raised 2 inches above the surface of the road. And then you remove the loosened bolts that you've already loosened them. You remove those bolts and you take off the tire. Then you head over back to the trunk and pull out the spare tire from the tire storage compartment. Bring the tire over to where the flat tire was and attach it to the car's leg. Then you bolt the tire on as tight as you can without bringing the car down. You're still you're basically attaching the tire to the frame of the car, and you're bolting it as tight as you can. Then you start to crank the jack in the opposite direction to lower the vehicle back down until the tire has begun to touch the ground. And then you tighten the bolts completely. After the tire has come down to the ground, you tighten the bolts completely. And then you remove the jack as well as take your tools and put them back in your vehicle's trunk. All right. Now, this is a pretty long list of instructions on what to do in the case of a flat tire. But if we treat this as a Java program, we could better organize this list into something called methods. Methods are nothing but named blocks of instructions, okay? You have a list of instructions and you wrap them up into something called a method, right? They're named blocks. We name this method and we wrap these instructions into that method. So if I was to wrap this long list of instructions into more organized procedures or methods, those procedures would be, generally these 4 steps: parking, getting the tools, changing the tire, and storing the tools back in your trunk. All right, just generally 4 major steps: parking, get the tools, change the tire, store the tools back in the trunk. All right, these 4 steps are basically methods. Methods are named block of instruction, right? The details for how to park in case of a flat tire and all of that, pulling on the side of the road, make sure you look in the rearview mirror, make sure there's no one approaching the shoulder of the road. All of those details will be wrapped into the parking method. Getting the tools, all right, that will be a different method, and in there will be details of how to get the tools. You look in the trunk, you open the storage compartment, pull out the tools, and so on. That's all going to be wrapped into this method called getting the tools. Then changing the tire, right? Cranking the jack up, making sure you loosen the bolts, all of those steps, all of those things are going to be in the changing the tire method, all right? And then finally, when you're all done, you store the tools and put the tire back. That's another procedure. So 4 basic methods or procedures can be used to summarize this entire list of instructions, this long list of instructions. So writing computer programs is about organizing these list of instructions into these named blocks of instructions, right? And you can think of these steps as literally code, right? We have 14 steps here listed. Each one of these can be thought of as a line of code, and we wrap these into these named blocks: parking, getting the tools, changing the tire, storing the tools, and putting the tire back. All right, so that's the way computer programming is supposed to be organized. We have these list of instructions, and we figure out, okay, what's the best way we can organize this list of instructions so that when I look at this later, I can very comfortably understand the computer program. The computer will basically assess all of your instructions, whether you give it in this 14-line list or you wrap them into these handy summarized methods such as parking, getting the tools, changing the tire. So organizing code is basically a way of programming, and object orientation is a way of programming. It's a better way of programming. We organize this long and complex list of instructions into these things called methods. In Java, everything in Java takes place because of methods. As a matter of fact, the starting point of every Java program is, in fact, the main method. That's where everything starts in a Java program. And then you can define your own methods and then call them in the main method, the starting point of our Java application, right? So we're basically calling these methods such as parking, getting the tools, changing the tire, storing the tools back. These are 4 methods. We are calling them in the main method, all right? And then we can actually call other methods. So if we had some sub-steps just in the parking itself, just in the parking alone, we can invoke other methods that have other details associated with them, right? So we have 4 methods. Each one of these methods could be further invoking other methods or calling other methods, right? That's how a program is built up. So instead of just this long list of instructions, we wrap these lists into these things called methods, and then we can call these methods in different parts of our program. Now, if you've just started learning Java, you might be wondering, what's a class? Well, a class is a place where you define your methods, all right? It's a container of methods. And that's it. Simply put, that's the best way to describe it. There's no complication there. A class is a place where you can define your methods. You can think of it as a file in which you put your methods. Now, you can have a file containing multiple classes, right? But the way I want you to think of a class is a place where you can define your methods. Now, there are other things you can define in a class, such as variables and so on. But you don't have to worry about that right now. You're going to be seeing plenty of examples coming up throughout the course. But a class is a container of methods, and a method is a container of instructions, right, on what to do and how a program should perform. So I'm going to wrap it up here. In the next lesson, we're going to go into the actual code, and you're going to see how this stuff works in Java. So stay tuned, and I'll see you soon.